Start recording. Okay. So our first question, what was f of x? 1 over 2x plus 0, okay? And we're using the definition of derivative. So that means f prime of x should look like this for us, okay? The limit as h goes to 0. We're going to put a plus h in there. Here we go. That's not that. Minus 1 over f of x all over h. Okay? You got to be able to get there at least. When you got a complex fraction, kids, we talked about multiplying through by 2x plus h plus 3 and a 2x plus 3. We are doing that because we want to cancel out the denominators that are in the numerator. Okay? So both of these are going to get multiplied to here and to here. You don't need to write a ton of work. You're going to tell me that what happens when you multiply them is that that first fraction cancels down to that, and the second fraction cancels out to this. Right? Right. All over h times 2x plus 2h. I'm just distributing that 2 in there. You don't have to do that necessarily, but I'm doing it to get rid of those parentheses. Any questions on that? We feeling okay with that step? You canceled it out. And once you got those complex fractions out of the way, we can just cancel everything out up top. If there was like a squared or something, we'd have to expand it out. If there were roots, we'd have to get rid of those. But this just cancels all the way down up top in that numerator. Okay, I'm not going to write this out again. I hope this makes sense. The 2x minus 2x cancels, right? Like this negative is going to distribute in there, which really makes it look like this. Bam, bam. Okay? The 2x's cancel, right? 2x minus 2x goes away. The 3's cancel. 3 minus 3 goes away. The only thing left on top is a negative 2h, but we're also dividing by an h. And like I told you, h has to cancel out every single time. So this h is going to cancel out with this h. And once that happens, you can plug in 0 for h. Okay? When I drop a 0 in for h, there's only one h left. That's right here. This thing just becomes a 0. So what we are left with is negative 2 over 2x plus 3 times 2x plus 3, which you are going to write as 2x plus 3 squared. Do we have that? Okay. The second one is a polynomial. What is it, like 2x squared? It's right behind. 3x squared. Come on. Minus 4x plus 5. 3, 4, 5. Okay, good. Which means I'm hoping you have this written out. The limit as h approaches 0 of 3x plus h squared minus 4x plus h plus 5 minus f of x, which is 3x squared minus 4x plus 5. And all that junk's going to cancel eventually all over h. Okay? Expanding all of that out gives us, notice how I am still writing limit. If you're looking at your paper right now and you didn't write limit down next to this until you plugged in 0 for h, you're just not writing everything you're supposed to be writing. Okay? This top thing right here, that x plus h squared, we talked about this, is really x squared plus 2xh plus h squared if you expand it out. Okay, so you can write that again if you want. I'm going to skip a step there and just distribute the 3 into that. So that's going to become 3x squared plus 6xh plus 3h squared. Cool. And then we have minus 4x minus 4h. That's this part right here. Then we have that plus 5. Then we have minus 3x squared plus 4x minus 5. And that looks like a heinous big old fraction. But it's going to boil all the way down to something super sweet and easy. I hope you can tell me the derivative already because we did the power rule, right? This derivative should be what? 6x minus 4 is what it should turn into. Okay? You can see the 6x, you can see the 4 in there. So 3x squared minus 3x squared is going to go away. So this is gone. And this is gone. Minus 4x and plus 4x goes away. And plus 5 minus 5 goes away. Okay? And then everything left has an h. We can cancel an h out. So this h is going to become a 1. That goes away. H squared here becomes just an h. And this h is going to become a 1. And that cancels with that. I divided h into all those things. And then if I put a 0 in for where that h is, you get 6x minus 4. Super sweet, okay? The last one had 2 steps in it. You got to get rid of the radical, and you got to expand the squared out. So let's take a look at that one real quick. So this is number 3, where f of x was the square root of what? X squared plus x, is that it? Yeah, okay? So the derivative of that thing right now, like I said, in like a week or two, I'm going to show you how to do this real quick in your head. You're just going to tell me what the derivative is, okay? But for now, we're really working on our algebra skills, making sure we're not making common mistakes, trying to root those out and get them out of here so the rest of the year isn't going to be too bad. But that's what that looks like. Everybody okay with that? The first thing I would do is get rid of those radicals. I don't want those square roots, okay? And the way we always will do that is by multiplying by the conjugate. Now the conjugate looks a little nasty because it's the first square root plus the second. And that means that's on the bottom as well. Look, I'm so lazy. Thank you, technology. Copy. Paste. Oh, man. Oh, man, it didn't... That wasn't as nice as I thought it was going to be. Oh, well. That's there. Okay? Everybody good? I'm moving this around an awful lot. When you multiply conjugates, everybody knows that you're going to get the first thing squared, which just gets rid of that square root, minus the second thing squared, but that's in parentheses, so that looks like that. Okay, and in the denominator we have this h, and we're multiplying by, how's this going to look? This whole ridiculous thing. So let's drop that up there. Okay? And now let's look, we see the x plus h squared there, we got to expand that out. That's not going to cancel until we expand that all out. So, we're going to get this, the limit. As h goes, and once we expand this out, everything is going to cancel out that we need. We have an x squared plus 2xh plus h squared, that's this piece. We have plus x plus h, that's this piece. And then we have minus x squared minus x, that's this piece. Okay, and again, our goal is to get rid of all those parentheses. That is all over h times the square root. And I'm not going to expand out the bottom. You can if you want, but again, the h is going to become a 0 eventually, so it doesn't hurt anything just to let it chill. And we're basically done. We're going to cancel everything out and plug in 0 and get our answer. Okay? So you can see x squared is going to cancel with this negative x squared. Plus x cancels with a minus x. Everything left in the numerator has that h, so we can cancel out an h. This h goes away. This h becomes a 1. This h squared becomes an h. And this h becomes a 1. So we are left with 2x plus h plus 1 up top. But h is becoming 0. And we can do that now because I canceled out my h. So it just becomes 2x plus 1 up top. And the denominator becomes, this is really x squared plus x now, because the h's became zeros. And we're adding to that the square root of x squared plus x. And since there's 2 of them, you write that as 2 times the square root of x squared plus x. Okay. And this is not super important at this point, but just for a little foreshadow, let me show you how we would do this like the short way, okay? So first off, you've got to notice that that's really to the 1/2 power. Is that okay? So we have something to the 1/2 power. When you derive the power, this is going to happen every single time, you multiply down that exponent and you subtract 1 off of it. So when I derive that, I should see a 1/2 appear. Now, we'll talk about what's going on with that inside, but I should see that somewhere. I should see 1/2, that thing to the negative 1/2. But the negative 1/2 just puts it in the denominator, and it's in a square root. That's what negative 1/2 means. Do you see our answer? How it's in the denominator right now? And it's in a square root? That's where that came from. That was the power rule. Okay? the 2x plus 1, anybody see where the 2x plus 1 comes from? What's the derivative of x squared plus x? 2x plus 1. That's why that's there. Okay? So, again, I don't expect you to be able to do that, like, just real quick, but eventually you will be able to just tell me that, bam, no problem. Okay? All right. Let me stop this. Hopefully that came out okay.